Hey there, in this video let's understand how one-dimensional arrays gets memory in our primary memory. So let's quickly get started. See, always remember our computer has two types of memories. First one is primary memory and the second one is secondary memory. So we have primary memories like random access memory, okay, and in secondary memory we have something called as hard disk drive, okay. Now always remember, whenever our program runs, it always gets storage in our primary memory. It doesn't get storage in the secondary memory, it always gets storage in the primary memory. And we already know why this happens, okay? We already know the reason behind why the programs get the memory in the primary storage when they run, okay? Now, whenever we talk about how the array is going to get storage, the arrays are always going to get storage in the primary memory, because as we know, when program runs they get storage in the primary memory. So obviously when we talk about arrays getting storage, they are going to get storage in the primary memory. Now let's get into more details of the primary memory and let's discuss how the primary memory actually allocates memory to our variables or to our arrays. So this primary memory is actually a long array of bytes. See, this is very important. See, primary memory is nothing but long array of bytes, and that's why we also call it as a byte addressable memory. Now I'll tell you why it is called as byte addressable memory. Let's assume like this red one is a primary memory, this one is our primary memory, and this single box is one place of that memory, okay. This one box represents one place in the memory, okay, and this place is basically one byte. See, one box represents one byte, okay, and we are calling it as a byte addressable memory because each and every individual byte of this memory, of this primary memory, is going to have one unique address, okay. See, we are going to talk about this term address in more detail when we are going to start with pointers module. Right now let's not worry too much about it. See, always remember, see, this primary memory is a byte addressable memory and each and every byte of the memory is going to have a unique address, okay. It's like our URL of our website, okay. Each and every website is going to have a unique URL. Similar to this, each and every byte in our primary memory is going to have a unique address, okay. I hope you are clear with this. That's why it is called as byte addressable memory. So always remember, the primary memory is a byte addressable memory, okay. Now let's assume that this is our primary memory, okay, and this is our array which is of character type and its name is ARR, and these are the three elements that we want to store in this array. It doesn't have any size, so it is by default going to take 3 byte of memory because we are planning to store 3 elements, or we are giving 3 elements in the initializer list. So the number of elements which are present in the initializer list will become size of the array, okay. So this ARR array needs 3 byte of size, okay. Now always remember, this is a very important point. In C++ or C++ compiler always allocates memory for your array in continuous fashion, okay. So basically in order to store these 3 elements you need 3 bytes. So 3 bytes in the RAM or in the primary memory will be allocated to you, and those 3 bytes will be one after another. You will get continuous memory. So this is the first byte, this is the second byte, and this is the third byte. Always remember, this is very important. Arrays get continuous storage. It doesn't matter whether it is a character array or integer array or float array, all the arrays are going to get continuous storage, okay. Now why C++ gives you a continuous storage? Let me tell you the reason. See, I'll give you one small example. Let's say you have multiple things. You have one pen, you have, let's say, one headphone, you have a mouse, you have one keyboard, okay. Now let's assume all these things are lying on your table, okay, and you are sitting near the table and now you want to get the pen. So what you can do is you can just take out your hand and then get the pen. And let's say you want to get the keyboard, then you can easily access the keyboard, you can easily access the mouse, you can easily access the headphone. Why you can easily access them? Because they all are around each other, they're at the very similar place, all right, they're on the table, they're on the same place, okay. And let's assume a different scenario. Let's say your headphone is present on your table but your pen is present on a different table, okay. And let's say your keyboard and mouse is present in your cupboard. Now in this case, let's say if you are sitting around your table, then you can easily take your headphone, but in order to take the pen, or in order to take the keyboard or the mouse, you will need to travel. Okay, you will need more time, right? That's why it's always better to keep the related things together. Okay, if we keep the related things together, it's going to be easy to access them, it's going to be easy to get them. Okay, and that's the only reason whenever we talk about arrays, it's going to be a homogeneous data and the things are going to be related with each other. That's why in order to simplify the access, in order to reduce the access time, we keep the data together, and that's why arrays gets continuous storage. So I hope you're clear with this point. Now in this case, this array is going to require 3 bytes of memory and we have 3 elements. So basically A will be stored here, B will be stored over here, and C will be stored over here. So in this way the array elements are going to be stored. Now let's consider a different scenario. Let's say I have a different array with name int arr, or let's say with name arr, and let's say in that array I have 2 elements, 1 and 2. Now how this array is going to get memory? See, in this case each and every element is of integer type, and we know that for each and every integer we need 4 byte of size, and even this 2 will need 4 byte of memory. Okay, so basically in order to store this array we need 8 byte, because each element needs 4 byte and we have 2 elements like that, so 4 into 2 is 8. That's why we need 8 bytes. So 8 continuous byte. Let's say we get memory over here, 1 byte, 2 byte, this is 3, 4, 5, 6, 7, 8. So this entire space will be needed in order to store this arr. Okay, and the first 4 byte, let's say this first 4 bytes will be allocated for the first element. So in these 4 bytes your 1 will be stored, and in these rest 4 bytes 2 will be stored. Okay, so basically 1 will be stored in first 4 bytes and 2 will be stored in next 4 bytes, because each and every integer needs 4 byte of memory in order to store them. So that's why the first 4 bytes are allocated to first integer and next 4 bytes are allocated to the next integer, and in this way the entire array is taking 8 byte of memory because there are 2 elements in the array. So I hope you're clear with this small concept, how one dimensional arrays get storage in the memory.